This is SageMaker Pipeline implementation. Orchestrate jobs to train and evaluate, sorry, models with Amazon SageMaker Pipeline. Orchestrate jobs to train and evaluate models with Amazon SageMaker Pipeline. This Amazon SageMaker Pipeline is tested for multiple regions, and this is a US West 2, and this is the um, type of the instance. Amazon SageMaker Pipeline offers machine learning application developers and operation engineers the ability to orchestrate SageMaker jobs and author reproducible machine learning pipelines. It also enables them to deploy custom built models for inference in real time with low latency, run offline inferences with batch transform, and tag lineage of artifacts. They can institute sound operational practices in deploying and monitoring production workflows, deploying model artifacts and tracking artifact lineage through a simple interface adhering to safety and best practice paradigm for machine learning development. The SageMaker Pipeline service supports a SageMaker Pipeline DSL, that is domain specific language, which is a declarative JSON specification. This DSL defines a directed acyclic graph, DAG, of pipeline parameters and SageMaker job steps. The SageMaker Python Software Developer Kit SDK streamlines the generation of the pipeline DSL using constructs that engineers and scientists are already familiar with. This notebook takes approximately 1 hour to run. We have contents like SageMaker Pipeline, then notebook overview, SageMaker Pipeline, dataset, define parameters to parameterize pipeline execution, define a processing step for feature engineering, define a training step to train a model, define a model evaluation step to evaluate the trained model, define a create model step to create a model, define a transform step to perform batch transformation, define a register model step to create a model package, define a fail step to terminate the pipeline execution and mark it as failed, define a conditional step to check accuracy and conditionally create a model and run a batch transformation and register a model in the model registry or terminate the execution in the failed state. Define a pipeline of parameters, steps, and conditions. Submit the pipeline to SageMaker and start execution. Pipeline operations, examining and waiting for pipeline execution, examining the evaluation, lineage, parameterized executions. SageMaker Pipelines. SageMaker Pipelines supports the following activities, which are demonstrated in this notebook. Pipeline, a DAG of steps and conditions to orchestrate SageMaker jobs and resource creation. Processing step, a simplified, managed experience on SageMaker to run data processing workloads, such as feature engineering, data validation, and model evaluation and model interpretation. Training job steps, an interactive, iterative process that teaches a model to make predictions by presenting examples from training dataset. Conditional execution steps are steps that provides conditional execution of branches in a pipeline. Registered model steps, a step that creates a model package resource in the model registry that can be used to create deployable models in Amazon SageMaker. Create model steps, a step that creates a model for use in transform steps or later publication as an endpoint. Transform job steps, a batch transform to pre-process data sets to remove noise or bias that interferes with training or inference from a dataset, get inferences from large datasets, and run inference when a persistent endpoint is not needed. Fail step, a step that stops a pipeline execution and marks the pipeline execution as failed. Parameterized pipeline executions enables variation in the pipeline executions according to specified parameters. A notebook overview. This notebook shows how to define a set of pipeline parameters that can be used to parameterize a SageMaker pipeline. Define a processing step that performs cleaning, feature engineering, and splitting the input data into train and test datasets. Define the training step that trains a model on the pre-processed data set. Define a processing step that evaluates the trained model's performance on test dataset. And define a create model step that creates a model from the model artifact used in the training. Define a transform step that performs batch transformation based on the model that was created. Define a register model step that creates a model package from estimator and model artifacts used to train the model. Define a conditional step that measures a condition based on output from prior steps and conditionally executes other steps. Define a failed step with a customized error message indicating the cause of execution failures. Define and create a pipeline definition in a DAG with defined parameters and steps. Start a pipeline execution and wait for execution to complete. Download the model evaluation report from S3 bucket for examination and start a second pipeline execution. A SageMaker pipeline, the pipeline that you create follows a typical machine learning application pattern of pre-processing, training, evaluation, model creation, batch transformation, and model registration. So these are the parameters: the processing instance count, processing instance type, training instance type, model approval status, input data, batch data, MSE threshold. So these are the input parameters. In the processing step, we do feature engineering, and the training step, we are training the model. And again, there is a processing step where we are doing model evaluation. And for model accuracy, we are using condition step. So there are if steps and else steps. So if the condition is acceptable, then we're creating a model. First, we are packaging creating a model, and then we are doing batch transform. And if it is failed, then if this condition is failed, then we are getting an error data set. The data set you use in the UCI machine learning Alboni Abalone dataset. The aim for this task is to determine the range of abalone snail from its physical measurements. At the core, this is a regression problem. The dataset contains several features: length, the longest shell measurement; diameter, the diameter perpendicular to length; height, the height with meat in the shell; whole weight, the weight of whole abalone; sucked weight, the weight of meat; viscera weight, the gut weight after bleeding; shell weight, the weight after being dried; in sex, male, female, or infant; and the rings is the integer. So basically, this is a regression problem. There would be a continuous number. We need to predict the age of this snail. The number of rings turn out to be a good approximation of age. The age is ring plus 1.5. However, to obtain this number requires cutting the shell through the cone, staining the section, and counting the number of rings through a microscope, which is a time-consuming task. However, the other physical parameters are easier to determine. You use the dataset to build a predictive model of the variable rings through these other physical measurements. Before you upload the data to an S3 bucket, install the SageMaker Python SDK and gather some constant you can use later in the notebook. So the data is from this DOAD and Graph C 2019 UCI Machine Learning Repository. Irvine, CA, University of California, School of Information and Computer Science. So this is a document which is took from AWS site, and this exclamation pip install hyphen use SageMaker. When we put exclamation mark in the shell, that means we are executing shell command. And hyphen u is to upgrade if it is already present. So this is to install the SageMaker package. And we are importing the modules like sys, Boto3, SageMaker, and pipeline context module. From this, we are importing pipeline session class. So this SageMaker dot session dot session. So this session class, this we are storing in SageMaker session. The connection we are storing here. And SageMaker session, the same connection dot Boto region name, we are storing the region. SageMaker dot get execution role, the role required to run the jobs we are storing inside role variable. And the pipeline session, like the pipeline connection, we are storing in the pipeline session. SageMaker session dot default bucket, this we are storing in default bucket. And this abalone model package group name, this name we are storing in model package group name. Now upload the data into the default bucket. So these are the variables which we have set it. Now we have to upload the data into the bucket which we have in this default bucket variable. You can select your own data set from input data URI as appropriate. So this data folder, and we have this abalone dataset.csv. This file we are storing in this variable. But before this, if you'll see, we are running the shell command to create a folder, and if it is present, then it is verifying. Then for S3 resource, we are talking with the help of Boto3, and we are storing it in S3 object. And then on this object, we are using bucket class and passing the name to this bucket. And then we are using .download file method and passing the folder and the file name. So this needs to be stored in the local path, which we have already set it. So it is downloading, and then it is storing it in the local file system, local file path which we have defined. This URI is 3:/ and this default bucket which we have already created, and Abalone folder. This is a base URI, and in the base URI we are using this SageMaker.s3 uploader class, and then we're using .upload method. In the .upload method, we are passing the local path which we have set it, and the base URI which we have set it to the desired S3 URI, and then we are printing this input data URI, this particular object we are printing. Download a second dataset for batch transformation after model creation. You can select your own dataset for the batch data URI as is appropriate. So this is a folder and which we have set it as local path. And again, we are creating, we are talking to S3 with the help of Boto3. And then in this object, we are using .download file method and passing the argument like local path. And this is the file, and this is the local path. So it is downloading this file to this location, to this path. And this is the file path which we have set it for, that is the base URI. And inside this base URI, we are using SageMaker and using .upload method to upload the file. And we are passing the local path that we have already set it and the desired path, that is the base URI, that S3. And then we're just printing the batch data URI. So now our batch data URI is set it and input data URI is set it. From where we will input the data that is being uploaded, and the data for batch transform we'll use that has been downloaded and uploaded. Define parameters to parameterize pipeline execution. Define pipeline parameters that you can use to parameterize the pipeline. Parameters enables custom pipeline executions and schedules without having to modify the pipeline definition. The supported parameter types include this parameter string that represents a string Python type, parameter integer that represents int Python type, and parameter float that represents float Python type. These parameter supports providing a default value which can be overridden on pipeline execution. The default value specified should be an instance of the type of the parameter. The parameter defined in this workflow include processing instance count, the instance count of the processing job, instance type that starts with ml.asterisk, model approval status registered with trained model for CI/CD purposes. Pending manual approval is the default. Input data, that is S3 bucket URI location for input data, and batch data is the S3 bucket URI location for the batch data. And we have MSE threshold, that is mean squared error threshold used to verify the accuracy of the model. So these are the parameters. So this particular code is to set parameters. So from parameter module, what we are importing, parameter integer, string, and float. And then in the integer parameter, we are using the processing instance count, that is 1, instance type, that is X large, and this approval status, that is pending. And this we have used for processing instance count. Instance type, we have used mode, approval status, input data, this is for, and batch data, and this is for MSE threshold, that is 6. So if it is greater than 6, then it will fail. So all the parameters are defined here. Define a processing step for feature engineering. First, develop a pre-processing script that is specified in the processing step. This notebook cell writes a file, pre-processing abalone.py. This is a pre-processing script which contains the pre-processing script. You can update the script and rerun this cell to overwrite the pre-processing script using scikit-learn to do the following. So this script is using scikit-learn to fill in missing sex categories and encode it so that it is suitable for training. It is filling the missing category and encoding it so that it is suitable for the training. Scale and normalize all numerical field, and then it is splitting the data in train, validation, and test data set. So this is done by using the scikit-learn framework. The processing step execute the script on the input data. The training step uses the pre-processed training features and labels to train a model. The evaluation step uses the trained model and pre-processed test features and labels to evaluate the model. Again, we are using the shell command to create a folder code. And inside this folder, again, this is a magic command in the notebook cell that is to create this pre-processing.py script. And these are the modules which are being imported. And since we get a headless CSV file, we specify the column name here. So these are the feature column names. And this is a label to this column. And these are the data types to these feature columns. And this is the label data type for this ring. And this is the function which we have created by passing x and y parameter and copying x to this z variable, and then on top of this variable we are applying update method to update the values of y and then returning this variable z. If name equal to main, so this condition, if this is the condition, this is the logic, and it will have the base directory. So we have created this processing folder, and then we are reading this file, and these are the columns, and this feature column names which we have set it, we have converted into list, and then we are removing this sex column, and then with this pipeline class we are passing um, the step parameter, and inside step we have these parameters: imputer, which have the median strategy, and scalar, which have standard scalar class. And then this is numeric feature, then we have categorical feature, that is this, and then with the pipeline class we are passing this parameter imputer where the strategy is constant, and fill values missing, and we one hot handle unknown ignore, and then column transformer class we are using, and we are passing the transformer and this is num, where we are passing the numeric feature, and category we are passing the categorical transformer and the feature. And this is, we are then popping this ring, removing this ring, and then on this pre-process object, we are using dot fit transform method on this data frame, and this is x pre, and this is y pre on the y dot numpy dot reshape len of y comma 1. That is series and that is tabular. Now numpy dot concatenate this see list, single list, one dimensional, and this multi-dimensional, and this axis is 1, that is column 1, and then np dot random dot shuffle, and then we are shuffling this particular matrix, and we are splitting in train, validation, and test. That is 0.7 into x, 85 into len of x, and then pd dot data frame on train to CSV. Now we are saving it to CSV, and this is the train.csv name, no header, no index. Same for validation, no header, no index, and this is validation.csv file. And then same, we are saving to CSV, that is test.csv. Next, create an instance of sklearn processor and use that in processing step. You specify the framework version to use throughout this notebook. Note that processing instance count parameter used by processor instance. So from processing module, we are importing sklearn processor, and to this sklearn processor, we are passing the parameter like version, instance type, instance count, and the name, role, and the session. This is sklearn processor. Finally, we take the output of the processor's run method and pass that as an argument to the processing step. By passing the pipeline session to the SageMaker session, calling .run does not launch the processing job. It returns the arguments needed to run the job as a step in the pipeline. Now, train data, the test data name channel specified in the output configuration for the processing job step properties can be used in subsequent steps and resolved to their runtime values at execution. Specifically, this usage is called out when you define the training step. So in the processing module, we're importing processing input class and processing output class. And then from a step module, we are importing processing step. And the object which we have created sklearn processor, on that object we are running .run, and we are passing the input, output, and code parameters. In the input, we are passing the input folder, and in the train we are passing train folder. In the validation we are passing validation folder, and in the test we are passing test folder. And this is the code, and then we have used this particular class processing step class, and then in this class we are passing the arguments which we have created with .run method, and we've created a step process. So one process is created. Processing step is done. Now define a training step to train the model. In this section, use Amazon SageMaker XGBoost algorithm to train on this dataset. Configure an estimator on the XGBoost algorithm and input dataset. A typical training script load data from input channel. Configure training with hyperparameters. train a model and saves a model to model dir so that it can be hosted later. The model path where the model from the training are saved is also specified. Note the instance type parameter may be used in multiple places in the pipeline. In this case, the instance type is passed into estimator. So from the estimator module, we have imported estimator class, and from input module, we have imported training input. So this is the S3 um, path, which we have S3 colon forward slash, and this abalone train folder, which we have set it. And on the SageMaker dot image URI dot retrieve. So with dot retrieve method, we are passing the arguments like framework. We are using XGBoost, in which region, what version, what Python version, and the instance type. And these all arguments we are passing for this image URI, because this URI we will be using. And in the estimator, we are passing the image URI argument, instance type, instance count, output path, and role and SageMaker session. This is common in every configuration that we have to pass the connection, and along with the connection, the role. And this we have, for this we have created xgb underscore train object. And then on this object, I'm running the set hyperparameter method and passing the arguments like objective, that is a linear regression problem, a numeric round, the number of trees, and each tree um, have 5 iteration, and ETA, learning rate, gamma 4, restriction, min child weight, subsample. There are few hyperparameters. And on this HGB train, we're using dot fit method. And in the dot fit method, I'm passing input and content type. And inside the input, we are passing train and the validation. In the training input class, where we have given the S3 URI from this processing step, and same for validation. We use this validation. Finally, we use the output of estimators dot fit method as the argument to the training step. By passing the pipeline session to the SageMaker session, calling dot fit does not launch the training job. It returns the argument needed to run the job as a step in the pipeline, just returning the argument. Okay, pass in the S3 URI of the train data. Output channel to the dot fit method. Also use the other test data output channel for model evaluation in the pipeline. The properties attribute of the pipeline step matches the object model of the corresponding response of a described call. These properties can be referenced as placeholder values and are resolved at runtime. For example, the processing step properties attribute matches the object model of the described processing job. And this is inputs module, and we're using training input class. And from a step module, we're using training step class. And then in the training step, we're passing the name and the step arguments, and the arguments which we have defined in train hours. So now the training step is done. Define a model evaluation step to evaluate the trained model. First, develop a evaluation script that is specified in a processing step that performs the model evaluation. After pipeline execution, you can examine the resulting evaluation.json for analysis. The evaluation script uses XGBoost to do the following. Right. load the model, read the test data, and it issue the prediction against the test data, build a classification report, including accuracy, and it save the evaluation report for the evaluation directory. Now this is the evaluation script, and this is the magic cell where it is in one cell. This is a line of commands in this evaluation.py script. JSON, pathlib, pickle, tar file, joblib, numpy, pandas, xgboost, and this matrix we are importing mean squared error. So these are the modules which we are importing, and this is the logic. So first is that is .tar.gz is the model path, and then with this tar file function we are running .open method, and we're passing this particular path, and then we are extracting this the current location. Okay, now we are opening this xg pickle.load open xgboost model in binary in this, and then we're using test.csv in the test path, and we're reading that data in data frame with the help of pandas, and then this is a series, a list, and this is column 0 if it's true, xgboost, this particular model we have used, and we are using dimensional matrix df dot values. Now we are using this is multi-dimensional data that we have stored in X test, and then with the model dot predict we are with the help of this XGBoost model we are predicting this set of test data, and the values are stored in the predictions, and then we are calculating mean squared error on prediction against the uh, that one-dimensional list data, and then the standard deviation, that is y-test minus prediction with the help of numpy, and then regression metrics, and this is key, and inside this we have MSE as a key, and this is then we have value as a key, and the standard deviation as a key, and then these are the value MSE and STV. So these standard deviation and MSE values are stored in this report dictionary, and this is the evaluation folder directory which we have created, and on pathlib.path on this directory we are running .mkdir method, and this is evaluation.json. This is evaluation path, and we're opening this particular evaluation path in write mode, and then we are writing json.dump. From this we're storing it into this .json. Next, create an instance of script processor and use it in the processing step. Then from the processing module we are importing script processor, and in the script processor class we are passing image URI, command, instance type, instance count, job name, role, and SageMaker session. These are the parameters. And then on the script eval parameter I'm running .run method where I'm passing the input, output, input, this is input, this is output, and this is code, similar to like I have passed in earlier steps. Use the processor argument returned by .run to construct a processing step along with the input and output channel and the code that will be executed when the pipeline invokes pipeline execution. Specifically S3 model artifacts from step 3 Properties and STURI of the test data output channel of the step process. Properties are passed as input. The training step, processing step, properties, attribute matches the object model of this training job and processing job. Response objects respectively. From properties module, I'm importing property file class, and in the property file class, I'm passing name, output name, and path. These are the parameters which I'm passing. And in the processing step, the name and the step argument in the property file. That is the evaluation report. So now the model evaluation is done. Now we have to create a model. So we have to define a step here. In order to perform batch transformation using the example model, create SageMaker model. Now I have to create a model first. Specifically pass in S3 model artifact from training step train properties. The training step properties attribute matches the object model of described training job response object. So from this module, I'm importing this model class, and in the model class, I'm passing image URI, model data, SageMaker session, and role as an argument. So this will create a model then. Define the model step by providing the return values from model.create as the step argument. So this image URI from this input module, I'm importing create model input class, and from model step module, I'm importing model step. And in the model step class, I'm passing name, step arguments, and accelerator type. So in the step argument, that is model.create method, and then the instance type and this accelerator type. These two arguments I'm passing in dot method. Define a transform step to perform batch transformation. Once the model is created, here the model is created, now we can do the transform step. So for transform step, this is define a transform step to perform batch transformation. Note that a model instance is defined. Create a transformer instance with the appropriate model type, compute instance type, and desired output S3 URI. Specifically pass in the model name from the create model step. Step create model properties. The create model step properties attribute matches the object model of the described model response object. So this is from transformer module. We are importing transformer class. And in the transformer class, we are passing model name, instance type, instance count, and the output path. Pass in the transformer instance and the transform input with batch data pipeline parameter defined earlier. Input module, we're importing transform input, and from the step module, we are importing transform step. And in the transform step, we are passing name, transformer, and the input, that is transform input, that is batch data. After doing this batch transform, then we have to register a model to create a model package. Then we have to package the model. A model package is an abstraction of reusable model artifact that packages all ingredients required for inference. Primarily, it consists of an inference specification that defines the inference image to use along with an optional model weight location. A model package group is a collection of model package. A model package group can be created for a specific ML business problem, and new version of the model package can be added to it. Typically, customers are expected to create a model package group for a SageMaker pipeline so that model package version can be added to the group for every SageMaker pipeline run. To register a model in the model registry, we take the model created in the previous step. So this is the model class, and we're passing image URI, model data, SageMaker session, and the role. And we're calling the dot register function on it while passing all the parameters needed for registering the model. We take the output of dot register call and pass that to model step as a step argument. From model metrics module, we are importing metrics source and model metrics. And this model metrics class have the parameters model statistics. No. Okay, model statistics and content type. In model statistics, that is the model metrics class. And we have model statistic, and this is metric source class, and this is S3 URI, and that is the evaluation.json. And on this, we are running this dot format method, and we're passing this step eval dot arguments, that is processing output config output. This is first, and this is S3 output. This is URI. So we are accessing the URI, and then on then we are calling this dot register function by passing the arguments required to run this to register this. So that is content type CSV, response type CSV, inference instance, transform instance, model package group name, approval status model, and this is model metrics. Now we are done with this register model step. Now define a fail step to terminate the pipeline execution and mark it as failed. This section walks you through the following steps. Define a fail step with customized error message, which indicates the cause of the execution failure. Enter the fail step error message with a join function, which appends a static text string with the dynamic MSE threshold parameter to build a more informative error message. So this is fail step module, and we are importing fail step class, and from this function module we're importing join. In the fail step class we're passing name and the error message, and now this is also executed. Now define a condition step to check accuracy and conditionally create a model and run a batch transformation and register a model in the model registry or terminate the execution in the failed state. In this step, the model is registered only if the accuracy of the model as determined by the evaluation step exceeded a specified value. Otherwise, the pipeline execution fails and terminates. A conditional step enables pipeline to support conditional execution in the pipeline DAG based on the condition of the step properties. In the following section, you define a condition less than or equal to on accuracy value found in the output of the evaluation step. Use the condition in this list of condition in a condition step. Pass the create model step and transform step and register model step collection into if steps for the condition step, which are executed if the condition evaluates to true. Pass the fail step into the else steps of the condition step, which is only executed if the condition evaluates to false. Now, from this conditions module, we're importing condition less than or equal to class, and from condition step, we're importing condition step class. From function class, we're importing JSON get. Condition less than or equal to, for this class, we're passing left and right. Left is JSON get. In this class, we're passing a step name, property file, and JSON path parameter value. And in the right, we're passing the MSC threshold, that is 6.0. In the step condition, step, we are passing the name, conditions, if steps, and else steps. In the if steps, we are passing a step register, step create model, step transform, else step fail. Define a pipeline of parameters, steps, and conditions. In this section, combine the steps into a pipeline so it can be executed. A pipeline requires the name, parameters, and steps. Names must be unique within a pair. Note, all the parameters used in the definitions must be present. Steps passed into the pipeline do not have to be listed in order of execution. SageMaker Pipeline service resolves the data dependency DAG as steps for the execution to complete. It resolves the dependency automatically. Step must be unique to across the pipeline step list, and all condition is step, if or else list. From pipeline module, importing pipeline, and this is the pipeline name, and then the pipeline class, and passing parameters like name, and the parameters like processing instance count, instance type, model approval status, input data, batch data, and MSC threshold. And in the steps, we're passing step, process, step, trains, evaluation, and condition. So this is how we do SageMaker pipeline training. This is like how we register the artifact. Examining the pipeline definition. The JSON of the pipeline definition can be examined to confirm the pipeline as well, defined, and parameter and step properties resolved correctly. This is import module and JSON.loads, and this is loading the pipeline.definition, and then we're just calling this object. Submit the pipeline to SageMaker and start execution. Submit the pipeline definition to the pipeline service. The pipeline service uses a role that is passed in to create all the jobs defined in the steps. Pipeline.upsert, and then the role that we pass the parameter, and then start the pipeline, except all default parameters. Pipeline.start, and pipeline operations, examining and waiting for pipeline execution. Describe the pipeline execution. Execution.describe, execution.wait, execution.list the step, examining the evaluation. Examine the resulting model evaluation after the pipeline completes. Download the resulting evaluation.json file from S3 and print the report. So from pprint module, we're importing pprint. And then the SageMaker.s3 downloader.read file. This read file method, I'm passing this particular parameter. And then JSON.load this evaluation underscore JSON. And lineage, review the lineage of the artifact generated by the pipeline. Import time, and from visualizer module, we're importing lineage table visualizer, and then from table visualizer, passing SageMaker.session method, and for execution step, in reversed execution.list steps, print execution step. So this is a loop which will run, and it will display res.show method, and this method will show the pipeline execution step, that is the execution step, and the time sleep is 5. Parameterize executions. You can run additional execution of the pipeline and specify different pipeline parameters. The parameters argument is a dictionary containing parameter names where the values are used override the default values. Based on the performance of the model, you might want to kick off another pipeline execution on a compute optimized instance type and set the model approval status to approved automatically. This means that the model package version generated by register model step is automatically ready for deployment through CI/CD pipelines, such as the SageMaker project. Yeah, we can create the SageMaker project where we have the CI and CD repository to run the pipelines. Execution pipeline.start parameter and this is state model approval status is approved. Execution.wait, execution.list steps. Apart from that, you might also want to adjust the MSE threshold to smaller value and raise the bar for the accuracy of the registered model. In this case, you can override the MSE threshold like the following. Threshold 3.0. If MSE threshold is not satisfied, the pipeline execution enter the failure step and it mark as failed. So this is the overall, I would say, steps, and that is starting from setting up the parameters, running process, step, train step, evaluation step, condition step, and then create model step, then transform step, and then register it. And then if the accuracy is not as per the threshold, then it will fail.